Hello everyone, and welcome to today's SQL Beginners Level Workshop. My name is Alex, and I am your instructor for this session. I'm excited to be here with you, and we are going to have a good time coding in SQL today. Let's take a look at our agenda. I will briefly talk about myself, and then we dive right into talking about SQL. Why is it important for you to learn SQL? We talk about data, databases, and database management systems, which are very important concepts in learning SQL. Then we talk about what exactly is SQL. We talk about SQL dialects. Then we explore the main data types in SQL, integers, strings, and date and time data types. Then we look into data definition language, DDL, and the commands that falls under data definition language. Subsequently, we talk about SQL constraints. We look at the null and not null constraint and the default constraint. Then we have a recap and then talk about the next steps going forward. Most of our time will be spent coding in SQL. The idea of today's workshop is that you're able to code along with me. We will spend some time, of course, defining and explaining certain concepts, but besides that, all we'll be doing today is coding in SQL. As mentioned earlier, my name is Alex, and I have been working extensively with data for over 5 years. Professionally, I have worked as a data analyst, business analyst, and SQL has been one of the primary languages I use for data analysis. I have been teaching SQL formally for over 3 years, both in person and online. As much as I would like to go on and on about myself, I think the time would be best spent talking about why we are all here today, which is SQL. In order to learn SQL, we need to download and install some applications. The next two videos would walk you through downloading all we need in this course. The first video is for those with a Windows computer, and the next video is for Mac users, so you don't have to watch both videos. Once you successfully download and install the applications, we can start learning SQL. The download links will be provided in the resources folder. The video also shows a walkthrough of how to get to the download pages through Google. If you have any trouble with downloading or installing the applications, please send me an email. Hey there, welcome to my Learn T-SQL Complete course. In this video, I will walk you through installing Microsoft SQL Server on your Windows computer. If you'd like to install Microsoft SQL Server on your MacBook, check out my video, Install Microsoft SQL Server on Mac. You can find the link in the description below. From your web browser, go to google.com and type in download SQL Server. The first link should be a Microsoft page. If not, be sure to look for the page that starts with Microsoft.com and has a pathway to SQL Server downloads. Click on the link and this should take you to the download page for the most recent SQL Server version. As of the making of those videos, SQL Server 2019 is the most recent version. Scroll down as what we want is the Developer Edition. SQL Server 2019 Developer Edition is a fully featured free edition which can be used as a development and test database within a non-production environment. Go ahead and click on Download Now. Select the location you want the file to be downloaded and click on Save. Once the download is completed, open the folder where you have the download file and double-click on the file. If you get a pop-up, click Yes to allow SQL Server 2019 to make changes to your computer. From here, click on the basic installation type. Then accept the licensing terms. This shows you the default installation location. Installing the files could take 10 to 15 minutes. Click on Install. Once the installation is complete, you should have the screen. On the left are some information about the installation. It is possible to install multiple SQL Server on your computer. Each of the installation is called instance, and each instance has its own collection of databases, objects, and users. The default name of the first instance is typically MS SQL Server. When you install another instance, you'd have to choose a different name. SQL Server Administrator is the person who has access to the server. Since this server is installed on your computer, by default, you are the SQL Server Administrator. The next step would be to install SSMS. SSMS stands for SQL Server Management Studio. SSMS helps us to connect to our SQL Server using a Graphic User Interface (GUI). Another way to connect to the SQL Server is by using a Command Line Interface (CLI). Go ahead and click on Install SSMS. A new page should pop up on your browser to download SSMS. Scroll down and click on the first link to download. And here you'd have an option to choose where you want the file to be saved. I will choose my downloads folder. Open your downloads folder and double click on the SSMS installation file. If you get a pop-up to make changes to your computer, click on Yes. On the screen, click on Install. The installation will take between 15 to 20 minutes to complete. Now that we have our SSMS installed, you can go ahead and close this. For easy access to the SQL Server, I will add SSMS to my taskbar, and to do that, just click on the Start menu, scroll down to Microsoft SQL Server Tools, click on Microsoft SQL Server Management Studio, right-click, and then click on Pin to Taskbar. Hey there! In this video, I will walk you through installing SQL Server on your Mac operating system. There are 4 applications we need to successfully install SQL Server on your Mac. At the moment, SQL Server is not designed to run on Mac operating system, but we can solve that problem by installing a virtual machine. A virtual machine is an application that can be used to run different operating systems within your host computer. The name of the virtual machine we will install is VirtualBox. Next, we will install Windows 10 ISO image. Once that is completed, we will install the SQL Server 2019 Developer Edition, which is a free SQL Server that can be used in a non-production environment. As of the making of this video, SQL Server 2019 is the most recent edition. Finally, we will install SSMS SQL Server Management Studio, which is the graphic user interface that allows us to connect to SQL Server. The download link will be provided in the video description, and I'll also show you how to get to the download page. From Google, type download VirtualBox. The first link should be from virtualbox.org, so click on the download link. And what you want to do from here is to click on OS X host. That will be the version for Mac operating system. And while that is downloading, I'll just open a new tab. And let's move on to our next download, which is to download Windows 10 operating system. And we want the ISO image. So click on the first link, and that should take you to the main page. On the download page, just scroll down, and we want to select our edition. The edition we need is Windows 10 and click on confirm. And now you have to select your language. For me, it will be English. Then confirm. Just going to take a few seconds. And next we want to download the 64 bits. This is a fairly large file, so it will take some time before the download is completed. While that's been downloaded, I will download the next, which will be SQL Server 2019. So just type download SQL Server 2019. And the first link will be from Microsoft, and just click on that link. And you want to scroll down as we have different download options, but we want the developer edition. So click on download. Now I already have this downloaded, so I won't go through that step again. So next, let's download our SQL Server Management Studio. Just type download SSMS, that should be good. The first link would be the download link. And you want to scroll down a little bit and click on the download link for SSMS. So all of this download should be done in about 20 minutes or so. Once the download is completed, then we'll start installing the applications. Once the downloads are completed, click on Finder, select your downloads folder or wherever you downloaded all the applications. And we should have all these 4 applications that we downloaded. Next will be to install the VirtualBox. Double click on VirtualBox, and I'm just going to reduce or minimize those pages. And the installation is fairly fast, so it should be completed in a matter of minutes, so three minutes or so. Now you double click on number 1, so the first step, just double click on that icon. Click on continue to run the program. Then continue. And you can change the installation location if you choose to do so. Just click on install, enter your password, the password to your computer. And now the files will start installing. Now this is an important step in the installation. You should get this pop-up, System Extension Blocked. All you need to do is to click Open Securities Preferences and then give permission for VirtualBox to be installed on your computer. But sometimes this pop-up doesn't display on time, or you may simply not notice the pop-up, and what ends up happening is that your computer blocks the installation, which then leads to a failed installation. Now, if you see installation failed, don't worry about it. Simply click Open Security Preferences, click the lock, enter your password, and click Unlock. And now you just have to just click Allow to allow Oracle America to be installed on your computer. So pretty much just allowing the VirtualBox to be installed on your computer. If you did not see the security preference box, don't worry about it. Just click on Settings on your taskbar. Now click on Security and Privacy. Click on the lock. Enter your password and click on Lock. And right here you should have the option to allow VirtualBox to be installed on your computer. Next, we just close this box because we'd have to reinstall the application. And just double click, continue, and now install, and then enter your password, install the software, and this should do it now. Alright, so successfully installed. We can go ahead and close this. And close this as well. There are a couple of ways of opening VirtualBox. You can click on the search icon at the top right corner of your computer, type VirtualBox, and from there you can double click to open it. You can also click on Launchpad, and from here you can double click to open VirtualBox. Once you launch VirtualBox, you will see the VirtualBox Manager. Now yours will be clean, it will look different. I already have a Windows Server installed inside of VirtualBox. Yours won't have any of this. So the next step for us would be to install Windows 10 operating system onto the VirtualBox. Next, click New, and now type Windows 10, which is what we are installing. And then the type should show Microsoft Windows. If not, click on the drop down to select Microsoft Windows and Windows 10 64-bit as well. And then click Continue. And I will increase the memory size to 4 gig and continue and just create. This is fine. And then we'll leave it at VirtualBox disk image, continue, and also just select dynamically allocated. And I am fine with 50 gigs as well, so just go ahead and click on create. Now we have Windows 10 uploaded to VirtualBox Manager, and we just need to do a couple of adjustments. So we need to click on Settings, and then from Settings, click on Advanced, and change the Disable to Bidirectional, and we change the drag and drop option to bidirectional as well. Now we go to Shared Folders, and this is where we'll be able to then connect the downloads folder on our MacBook to the VirtualBox. Because right now, all of the other downloads we have is within the downloads folder of our MacBook, and we have to find a way to connect because the VirtualBox is a standalone. Now we have a VirtualBox which is a standalone, pretty much a standalone computer of its own. And we need to be able to retrieve files from our MacBook and transfer those into the into our Windows 10 operating system. So what we'll do here is to connect our MacBook to the virtual. The next step is to click on the drop down on folder path, and we want to select our folder, the downloads folder. This is where I downloaded all the applications. So if this is where you downloaded the applications as well, or where you want to be able to transfer files between your MacBook and the VirtualBox, then you select that. For me, it's the downloads folder. And now you click on auto mount, click OK, and we click on storage. From storage, we want to click on empty. And then we click on the optical drive, we click on the blue icon and click on choose a disk file. And from here, we now select our Windows 10 download, so the ISO image. And we click on open to load the file itself. And then we click on OK. And now we are all set to run the application and install Windows 10 on our VirtualBox. Next, click on Start. And now click on the drop down because I have multiple applications, but we want to select the Windows 10 because that's the application we want to run. And you should only have Windows 10 showing on your drop down, and then we click on Start. And now we start running the Windows 10 application, and this would take some time. Might take around on average 15 to 20 minutes to install Windows 10 operating system. So now click on Next and click Install. And we can click I don't have a product key. And we want Windows 10 Home. That's fine. There are different editions, but this is all we need. Click on Next. And then agree to the license and terms. Next. And we have to select Custom Install. The size is 50 gigs, so that's fine. Click on Next. And the installation would start. And you can just click on that mic icon, the microphone icon, select your region. Hello everyone, and welcome to today's SQL Beginners Level Workshop. My name is Alex, and I am your instructor for this session. I'm excited to be here with you, and we are going to have a good time coding in SQL today. Let's have a look at the agenda for today. I will briefly talk about myself, and we dive right into learning about SQL. We talk about why we should learn SQL in the first place. We will talk about data, databases, and database management systems, and these are all important concepts, if you will, that SQL is built around. Then we talk about what is SQL. We look into SQL dialects. We also explore the different data types in SQL, focusing on the numeric, string, and date and time data types. Then I will introduce you to tables, how we create tables, and the purposes or what we use tables for. Then we look at the different commands or some commands on the data definition language, DDL. We look at the create, drop, and alter command. Then we look at SQL constraints. We look at the null and not null constraint as well as the default constraint. We have a quick recap of what we've learned so far, and then the next steps going forward. Most of our time will be spent coding in SQL. The idea of today's workshop is that you're able to code along with me. We will spend some time, of course, defining and explaining certain concepts, but besides that, all we'll be doing today is coding in SQL. As mentioned earlier, my name is Alex, and I have been working extensively with data for over 5 years. Professionally, I have worked as a data analyst, business analyst, and SQL has been one of the primary languages I use for data analysis. I have been teaching SQL formally for over 3 years, both in person and online. As much as I would like to go on and on about myself, I think the time will be best spent talking about why we are all here today, which is SQL. When we think about data or analyzing data, there are certain steps we sort of follow. First, we need to retrieve the raw data from a source location. Once we receive the data, we have to store the data somewhere, typically inside of a database. Then we start manipulating our data to derive certain insight from the data. Once that is done, we want to present our findings so that we can use that to make business decisions or whatever decisions we need from that data. SQL helps us to achieve all of these steps. Let's take a look at this ranking. Shortly, we will talk about database management systems, but to explain what this ranking is, most companies that use data in any form need to store their data in a database. In order to manage the data inside of the database, we need a database management system, and this ranking shows the popularity of different database management systems as of October 2020. Focusing on the top 5 most used database management systems, which are Oracle, MySQL, Microsoft SQL, PostgreSQL, and MongoDB. If we look at the database model, we can see that the top 4 model is relational database. All relational database management systems uses SQL to communicate with the database. MongoDB makes it into the top 5, but even if we look at the number, we can see that it is still relatively low compared to the top 3 most used database management systems, which are Oracle, MySQL, and Microsoft SQL Server. So we do know that SQL is one of the most commonly used languages for data analysis. Most data-driven companies use SQL in one form or shape, and this is across different sectors or different industry. Doesn't matter whether it's a big company or a small company, as long as data is at the center of what they do, a lot of companies use SQL. When we look at the number of data-related jobs with SQL as a key requirement, we can see that there is a high demand for professionals with SQL developer skill set. A recent survey identifies the top 5 most scarce skills as big data analytics, cybersecurity, artificial intelligence, enterprise architecture, and business analysis. Well, one common theme between all of those skills is data. And we know from what we've discussed that in analyzing data or storing data, we need SQL. So we can safely say that SQL is here to stay for a long time. All this to say that if you're still wondering whether learning SQL is the way to go, I can tell you that the importance and relevance of SQL cannot be overemphasized, and knowing SQL is key if you're considering a career in any data-related field. Before we start coding in SQL, I'm assuming you all received an email with a YouTube link on installing Microsoft SQL Server, which is the application we are using to learn SQL. The idea is we don't want you to simply watch me coding, but that you can also code along. However, if you don't have Microsoft SQL Server installed yet, you will still be able to learn a lot from this session. You can send us an email to info@techquesthub.com and we will send you the video link that walks you through the installation. Okay, so what is data? Data in its true form is unorganized and unprocessed facts, and it can be in form of numbers, images, sounds, characters, text, or videos. Data is typically derived from observations or measurements. And just to explain further, imagine on a given day you stand at the corner of your street. You notice people cycling on their bicycles. Now that's simply people going about their business cycling and has little or no meaning to you. But what if for a research project you want to find out the usefulness of bicycle lanes in your community? For this project, you may want to observe and measure how many people you see cycling at different times of the day, perhaps even see if there are peak times during a specific time of the day or a specific day of the week. Now, by observing and measuring, the cyclists that were once random now becomes a data source. Data, when processed, becomes information we can read, understand, and use. To define data, we can say that data is an unorganized and unprocessed fact and can include numbers, figures, images, characters, and are typically derived from observations or measurements. Next, what is a database? A database can be said to be a container where we store data. Earlier on, we established that data could be numbers, it could be text, it could be images. And what database does is that it really just stores our data. So we can define a database as an organized collection of data. The next item we will talk about is Database Management System, also known as DBMS. A database management system is an application used to manipulate, retrieve, and manage data in a database. Let's take a look at this image. We know that within our database, data is stored. But we need an application to retrieve those data from the database and present to either a user or to an application. One way to think about this is, imagine that you need to find the cheapest ticket from London to Amsterdam. You go to Google and in the search box you type find cheapest ticket from London to Amsterdam. Now that information is stored on the back end of Google. There is a database that contains that information. Well, in reality, it contains the data. But remember, we said that data, when processed, becomes information, right? So you go to Google and you type find the cheapest ticket from London to Amsterdam. Something has to retrieve that information from the Google database and present that information to you. And the application that does that is the database management system. Now, as you may imagine, there are different types of database management systems. However, for this session, we will be using Microsoft SQL Server. We did send you an email that contains information on how to download and install Microsoft SQL or SQL Server, I hope you were able to do that. If you still have problems or issues installing the application, please send me an email and I'll be glad to assist you with that. Okay, enough of all the talks. Why don't we get our fingers busy and start querying in SQL? I have SQL Server Management Studio pinned to my taskbar for easy access to Microsoft SQL Server. If you watch the video, the setup video I sent to you, that should show you how to do this. However, if you did not pin SQL Server Management Studio to your taskbar, that's fine. All you need to do is click on the Start menu and then just scroll down to M. And what you want to do under Microsoft SQL Server Tools, click on the drop down, and this is Microsoft SQL Server Management Studio, and you just need to click that to launch SSMS. SQL Server Management Studio helps us to connect to our SQL Server. So I'm going to go ahead and click on SQL Server Management Studio, and it should launch in a few seconds. Okay, so once SQL Server Management Studio is launched, all we need to do is connect to the server. To connect to SQL Server, click on Connect. And the first thing we should see on the left is the Object Explorer. All we will focus on is this Databases folder. When we click on the drop-down menu, we see two databases, basically the system databases. When we create our own database, which we will create shortly, we should see that below this database snapshot. Let's click on the system databases. Here we can see we have 4 different databases: Master, Model, MSDB, and TempDB. All those 4 databases contain data needed for the functioning of Microsoft SQL Server. I'm going to collapse this drop-down menu, collapse this as well. Now let's go ahead and click on New Query. This is the query box where we will type our SQL queries or SQL codes. The first thing I would like us to do is to include a line number. Right there you see it says number 1. You may not see that on your Microsoft SQL Server because this is the first time you're launching your SQL Server or SQL Server. The purpose of having a line number is if at any time you make an error within your code, you will get a message that tells you that there is an error, and it will indicate the line number where the error lies. So that's why it is important to have the line number. To insert the line number, click on Tools, Options, and then we want to scroll down to Text Editor. Click on Text Editor, and then under Transact SQL, I'm going to click that, and then when we scroll down, click on General, and all you need to do is check the line numbers box for the line number to appear. Click on OK, and you should have the line number inserted. The first thing I would like us to do is create our own database. So how do we create a database? The syntax to create a database is we type create database followed by the name of the database. The 2 words create and database are what we call keywords in SQL. Keywords are reserved words that are used to perform various operations in the database. Now let's switch over to SQL Server and create our own database. Alright, assuming we want to collect information about different restaurants and we need a database to store those information. So we want to create a database and the name of the database will be restaurants. How do we do that? All we need to do is we type create database and then followed by the name of the database, which will be restaurants. Now, the way when we write queries in SQL, we need to end the query with a semicolon. And by ending the query with a semicolon, this is telling SQL Server or SQL Server that we are done with that particular query. Now, we have our two keywords, create database, followed by the name of the database, restaurant. Another thing that you'd notice is that when I typed create database, I typed those two words in uppercase and restaurant in lowercase. The reason is because the rule of thumb when you're writing a query in SQL is that anytime that you write a keyword or keywords that belongs to SQL, you want to write those in uppercase. And whenever you write words that we imputed, for instance, restaurant, we chose that name for that database, then we write that in lowercase. One of the reasons why we do this is just to distinguish between SQL keywords and words that we imputed. And it sort of also makes the query looks clean. So to run this query, all we need to do is you want to highlight this query and then we click on execute. Now below we see a response to the query that we just executed. Command was completed successfully. This shows us the time in which this command was executed as well as the duration it took to execute the command. Now that we have created a restaurant database, why don't we go into the databases folder and see if that restaurant database is there. So I click on this drop down menu. Oh, for some reason I only see the system databases and the database snapshots which were there before. Well, all we need to do is to refresh this folder. We just click on databases and then click on the refresh icon. And once you do that, now we can see the restaurant database that we created. Let's create a new database. And let's create a database, and the name of the database will be computers. We end with a semicolon to indicate that we're done with that query. We highlight, and to highlight you just need to click down and drag and execute, and now commands completed successfully. All we need to do, click on databases, refresh, and now we see our restaurant database has been created as well. So we can see how easy it is to create a database in SQL. The next step would be for us to select a particular database to work with. And this is because we know that right now we have the computers database, the restaurants database. We also have these 4 system databases. And we know also that database contains data. And if we have to work with a particular data, we have to choose or select which database that data is contained inside. So we have to indicate to SQL Server which database we want to work with. The syntax to select a specific database is we use the keyword use followed by the name of the database. So if we want to work with the restaurants database, all we need to do is we type use followed by the name restaurants. The same thing if we choose to use the computers database, we type use followed by computers, which is the name of the database. Let's switch over to SQL Server and try this out. Now, before we type the query to select a particular database, I want to point your attention to the top left corner of your SQL Server. Right here you see that it says master, and this is indicating the current database that we are inside of. So right now, when we see master here, or any database we see here, indicates the name or the database in which we are working inside of. Now, let's write the syntax to use the computers database. To do that, we type the keyword use followed by computers. We end with a semicolon to indicate that we're done with that query. Now let's run our query, and immediately we see that this changes to computers because now we are inside, or we are now able to work inside of the computer's database. Why don't we use another database? Let's use the restaurants database. Use restaurants, and then we execute, and now we see that the name changes to restaurants. Why don't we switch over back to the master database? To do that, we type use master. So what I'm doing there is I type the first two letters of master, and immediately I see a suggestion of a possible database that I might be trying to type. And this is what is called SQL IntelliSense. And all it does is that it sort of predicts what you're trying to type, or what the next thing what you're typing, essentially. Now, if that's exactly what I need, all I need to do is just press tab on my keyboard, and that selects that option. Okay, and then we end with a semicolon, execute, and now we can see that the database has been changed to master. So far, we know how to create a new database. We know how to select a specific database to work with. What if we choose to delete a database? How do we do that? The syntax to delete a database is simply drop database followed by the name of the database and ending with a semicolon. The keywords we have here is drop database. We have two databases that we created, computers and restaurants. Why don't we go ahead and delete both databases one at a time? We definitely don't want to delete any of the system databases because that will just mess with our SQL server. So let's delete the computers database first. And all we need to do is type drop followed by database and then computers. When we execute this command, right now we still see computers showing, but all we need to do is refresh this databases folder, and now we don't see the computers database anymore because we just deleted it. Next, let's delete the restaurant database. Execute. We refresh, and now we have no more database that we created. Okay, first let me say a big congratulations to you. In the last 15 minutes, you have learned quite a lot. We talked about databases, database management systems. For some of you, you wrote your first SQL code when you created a new database. You were also able to select a specific database to work with. And when you were tired of using that database, you simply deleted it. That's amazing. And again, good job. The next thing we will talk about is SQL. What exactly is SQL? This SQL that brought us all together, what's it all about? And then we will explore different data types in SQL, and I'll also introduce you to tables. SQL stands for Structured Query Language, and SQL is sometimes referred to as SQL, and you may have heard me use SQL and SQL interchangeably. SQL is the language we use to communicate with our database in a relational database management system. Earlier, I told you that we have different types of database management systems. Relational database management system is one of many other types of database management systems, and Microsoft SQL Server falls under a relational database management system. So, SQL is used to communicate with a database within a relational database management system. That really just means that there are other database management systems that does not use SQL to communicate with the database. They use some other type of programming language to do that. To visualize how SQL works, let's take a look at this diagram. We know that within our database, we have data, so data is contained in our database. And we have also our database management system, for us, Microsoft SQL Server, which we use to communicate with a database. SQL is that language that we use to facilitate that communication. So if you remember, we recently created a restaurants database as well as a computers database. And the language we used to do that was SQL. When we typed create database restaurants, that's SQL. When we typed drop database computers, that's SQL. So we used SQL as the language, sort of like the bridge between our application, our database management system, and our database. It's important to note that Microsoft SQL Server is not the only relational database management system out there. Other popular relational database management systems are Oracle, MySQL, PostgreSQL, and IBM DB2. However, because SQL is a standard, once you learn SQL with Microsoft SQL Server, you pretty much would be able to work with any relational database management system. I haven't said that because each relational database management system wants to distinguish itself. There are slight differences in some of the syntax used to perform certain operations, and they also have a proprietary name for their SQL. Microsoft SQL Server proprietary name is Transact SQL or T-SQL. Oracle database is PL/SQL. MySQL is simply MySQL. PostgreSQL is PostgreSQL, and IBM DB2 is PL/SQL. The key takeaway is this: once you learn SQL, it is easy to work with any database that uses SQL, because the main difference is with the features they offer and not the SQL language itself. Next, let's take a look at data types in SQL. Data type is an attribute that specifies the type of data. We have the numeric data type, string data type, and date data type. Under the numeric data type, we have two types of data that can be stored inside of a numeric data type. We have int, which stands for integers, and decimal, which is used to store decimal numbers. We have the string data type varchar, which is used to store character values, but can also accept numeric values. The date data type is used to store date and time values. If we look at the int data type, we can use it to store all numbers. 3, for instance, 9. It takes on both positive and negative values. So -54, -3. All of these can be stored under the int data type. Decimal data type is used to store values that has decimals, and it can also take on both positive and negative values. 3.5, 0.8, -4.2, -5.5. When we look at the string data types, the string data type is used to store character values, and this could be words. It could be a letter, it could be words. The varchar, which is variable character, can store between 1 and 8,000 characters. Another important point is that within string data types, we have to insert the values inside of single quotes. Here we have rainbow in single quotes, we have cookies, we have John. Another thing is that with string data types, it can take on both character values and numbers. And all we need to do is to insert the numbers in single quotes. And essentially, even though those are numbers, it becomes a character value. Now, you don't have to think too deeply into all of this that we've talked about so far, because once we start, working with these different data types, it would make more sense to you. Also, we can store a negative number within a string data type, because as long as we are able to impute those values inside of single quotes, then we are fine. Next, let's talk about tables in SQL. We know that data is stored inside the database. However, we need to have the stored data in the database organized and well structured. And this is where tables play an important role. The data in our database is contained inside of a table. Let's take a look at this customers table. Each column represents a field and each row represents a unique record. We have the first name column, last name column, the date of birth column, and the customer ID column. Now, each row is a unique record. So we have this row that belongs to Tom Bradley, date of birth January 10, 1995, with a customer ID of 1002. So the information we have in this row is unique to Tom Bradley. We can go down the list. We have Pooja Shah, May 11, 1990, and with a customer ID of 1221. We have Mary Thompson, June 20, 1995, with a customer ID of 2254. So in a table, we have columns, and then we have rows. And each column is also referred to as a field. Now, once we have an information, typically you could look at this as a cell, but it is also a field once an information is inserted inside of that cell. So this is a field, this is a column, this is a row. Earlier on we talked about data types, and we can see how this table is structured with different data types. We have the string data types because this contains character values. So the first name and the last name contains character values, which makes them a string data type. If we look at the date of birth, this contains information about dates. So this is a date data type. If we look at the customer ID, this contains integers, all numbers. So 1002, 1221, 2219, 2254. So this is a numeric data type. So having our data inside of a table helps us to achieve structure and efficiency with our data. Okay, so enough of all the talks. Why don't we switch over to SQL Server and write some new queries? The next query I will show you is how to create tables in SQL. But before I do that, I would like you to create a new database because we don't currently have a user-defined database. Earlier on, we created two databases, which we already deleted. So I'd like you to create a new database. The name of the database would be pets. All right, to create a new database, all we need to do is we type create database followed by the name of the database pets. We end with a semicolon, and now we can execute our command. If we refresh the databases folder, we should have our pets database. The syntax to create a table in SQL is we have the keywords create table followed by the name of the table, and then we open up a parenthesis and we have two arguments. First, what is the name of the column that we want in the table? So we write the column name followed by the data type. So essentially we have to indicate what type of data would be in that column. Now, if we want to have multiple columns, then we have a comma to separate the first column, and then we do the same thing to add a second column, which is we write the column name followed by the data type, and then we close the parentheses and end with a semicolon. Let's say we want to create a table that contains information about dogs. Since we intend using our pets database, the first thing we need to do is to switch into the pets database, because as you can see at the top left corner, we're currently in the master database. So we use our use pets command. And when we execute this, now we are in the pets database and we can create our table inside of the pets database. I'll write out the query to create a table, and then we go through the query together. Okay, let's go through this query together. The keywords to create a table is we have create table, followed by the name of the table, in our case would be dogs. We open our parentheses, and then the first argument is we write the name of the column which we want, which is name because we want to capture the name of the dogs. Now we have to indicate the data type of this column. Because we know the names will be in characters, then that's a string data type. So we write varchar to indicate a string data type. Earlier on I told you that varchar can contain between 1 to 8,000 characters. Now we have to pass the argument as to the total number of characters that we want this name to be. So what we're saying essentially is that the name of our dogs cannot be more than 30 characters. So we pass 30 inside of these parentheses. Because we want a second column, we have a comma. The second column will be the age. We want to capture the age of our dogs. So age will be in numbers, and it will be an integer. At least that's what we want. We want the age to be integers, whole numbers. So we have to indicate the data type, which is int. We close our parentheses, and then we have a semicolon to indicate that we are done with this query. All we need to do now is to execute this query. We can confirm that the dogs table has been created, and to do that, let's click on the pets database, the menu. And if we go to the tables folder, just click on the drop down, we can see that the dogs table we created has now appeared there. All those other tables we see are just system generated tables that contain information or data for the functioning of SQL Server. Let's create a second table. This time we want to create a table to collect information of cats. Again, I'll write out the queries and we'll go through it together. And we can pull this down. Okay, so let's take a look at the syntax. Again, we have a create table. The name of the table will be cats. We open our parentheses. The first column will be name. The data type is varchar. The maximum characters of the name is 30. We have a comma to separate the first column from the second column. The second column will be age, which is an integer. We have a comma, and now we have a third column, which is color, to capture the color of our cats. Because color will be in characters, then that will be a varchar. And now we also indicate that the maximum length of the color cannot be more than 30. We close our parentheses and then we end with a semicolon. Let's create our table. Execute. And now if we refresh the tables, now we have our cats table. So far, we've learned how to create database. We know how to use a database. And now we just learned how to create tables in SQL. I'm sure you'd agree with me that there's not much you can do with an empty table. So how do we insert records into a table? And that's what we're going to try our hands on right now. Let's take a look at the syntax to insert records into a table. We have the keywords insert into, followed by the name of the table. We open our parentheses, and we have to indicate which column we want to insert records into or insert values into. So we have column 1, and then we have column 2. If we have multiple columns, if we have more than 2 columns and we want to insert records into all of those, we have to indicate that here as well. We close our parentheses, and then we have the keyword values, which is really what value do you want to insert into those columns. So assuming that this is a string value, we have to input that in parentheses, or in single quotes. We have a comma, we have the second value, we close our parentheses, and we end with a semicolon. Let's insert some records into our docs table. To do that, we have the keywords insert into, followed by the name of the table, which is docs. We have 2 columns we want to insert records into. In parentheses, we indicate those 2 columns. We have the name column, we have a comma to separate the name column from age. We close our parentheses, and what are the values we want to insert into these columns? We want to insert the name Bella, so that will be the name of our first dog. Because Bella is a string character, or because this is a string character, we have to input this in single quotes. We have a comma, and then we have 4, which is an integer. For integers, we don't have to include or embed that in quotes. In quotes. We close our parentheses, and we end with a semicolon. To insert records into cats, we have insert into cats, we have the name, we have the age, we have the color, all separated by comma, in parentheses. The values we want to insert, we have Cindy, which is the name, Cindy's age is 5, and Cindy's color is brown. Let's switch over to SQL Server and write out this query. Just gonna scroll down a little bit. Okay. So I'll write out the query first and we'll go through it together. Okay, so we have insert into docs, the name, the age, and the values will be Bella in quotes, and then the age will be 4. Execute. We see the result says 1 row affected because we really only inserted 1 row of record, and it gives us the completion time. Let's insert some records into the cats table. Right. And now we have, again, for our cats table, we have the name, the age, the color, and the values will be Cindy will be the name in quotes because it's a character string data type. We have the int, the age is 5, and then we have the color, which is brown. Let's go ahead and execute this query, and that's been executed. So far, we know how to insert single records into our tables. What if we want to insert multiple records at the same time? That's also very possible. To do that, I will copy, let's insert some records into the docs table. And I'm just going to copy, so you could just copy the same query. I'm going to paste. And now, because we're really just using the same query, all we need to change is the values. So to insert another record, let's say the name, let's say the dog's name is Tom. And let's say Tom's age is 6. Now, to insert multiple records, all we need to do is separate the first record with a comma, and now we can open our parentheses and insert another record. Let's say the second dog's name is Woofy. So we have that in quotes, and Woofy's age is 5. And now we can close there. If we want to insert, let's say we want to insert 3 records at the same time, we separate with a comma, we open our parentheses, and let's say the name of the third dog is, let's say Poggy. We close our quotes, and now Poggy's age is 4. Now we can close this, and end with a semicolon to indicate that we're done with this query. Go ahead and execute. Now we see 3 rows affected because we just entered or inserted 3 different records. So far, we created 2 tables. We have the dogs table and the cats table, and we have successfully entered some records into both tables. The question is, how do we retrieve those records from both tables? The syntax to retrieve records from a table is, we have the keyword select followed by star, from, and the table name. So if we want to retrieve records from the cats table, we have select star from cats. From the dogs table, we have select star from dogs. The select statement really means that we tell an SQL server to retrieve all, or well, to retrieve, the star there means all. So we're saying retrieve all the records from the cats table. Give me all of the records you have from the dogs table. So we type select star from dogs. Okay, so let's take a look and see what this looks like. Select star from dogs. And now we execute. And now we can see the dogs table we created. We have the 2 columns, the name column, followed by the age column. We have Bella, age 4, Tom, age 6, Wolfie, age 5, and Poggy, age 4. The numbers we see here are the row numbers to indicate the number of rows we have. Let's print out the cats table. Select star from cats. Execute. And now we have the cats table we created with the records. We have name, Cindy, Cindy's age is 5, and Cindy is a brown cat. You can see how easy it is to create databases, to create a table, to insert records into a table, and also retrieve records from a table. What if we choose to delete our tables? Let's pretend that Cindy has been adopted, and our dogs, let's print out the dogs table. Bella, Tom, Wolfie, Poggy, all of our dogs, they've all been adopted. And we really don't see a need to keep the business. We just want to travel around the world and not worry about anything. We've made enough money. How do we delete the tables that we created? The syntax to delete a table is simply we type the keywords drop table followed by the name of the table. So if we choose to delete our cats table, all we need to do is type drop table cats. We end with a semicolon. Let's go ahead and delete our dogs table. And of course, we are sorry to see Bella, Tom, Wolf, and Poggy go, but they're going to a nice family. We're rest assured there's nothing to worry about, so we're fine deleting them from our database. So to delete this table, all we need to do is we type the keyword drop table dogs. And now we can execute. Commands completed successfully. Note that we still see our dogs table showing up here, but if we refresh the tables, now we see that we don't have the dogs table anymore. Let's print out our cats table. We select all from cats, we execute. Now we have Cindy, that's the last pet to be adopted, and now we can go ahead and delete this table as well. Again, we are sorry to see Cindy go, but Cindy is going to an amazing family. Execute, that's completed. When we refresh this, our cats table has been deleted. Before we move further, I would like to quickly show you how to add comments within our SQL commands or our queries. Because if we look at it so far, we've actually done quite a lot. You know, we created a database, created a table, inserted records, and deleted our table as well. And it's always good to, for different reasons, we might want to make different comments. So for example, we might want to say, how to create a table, just as a comment to separate those lines of codes. Right here, we might want to say, inserting records into our table. So writing or having comments within your queries is a very common thing. It is also possible that when you write your SQL commands or your queries, perhaps someone else might need to see that query. And by adding comments, you can use the comment to indicate what the query is all about or what you're trying to achieve with a particular set of queries. So the way to insert, and there are multiple ways in which you can insert comments within SQL, within your queries, but I'll show you the single line comment. And to do that, all you need to do is, I'm going to start from here. Let's say we want to insert, and I'm just pressing the enter key right here. Let's say we want to insert a comment here that says deleting our table. So first I'm just going to write it out. So deleting the dog's table. And right now you can see all of this is red, and this wavy line is sort of indicating that there's a trouble with this query. And that's because SQL is thinking all of this is some sort of query, what is one query, right? But that's not really it. So to make this a comment, all we need to do is you just type dash twice, and that's on most keyboard, that should be the key after 0, the number 0. So all you need to do is just press dash twice, and immediately you see that this goes green. And whatever we do now, it's not going to affect this query. Right now we can't run this query again because there's really no dogs table, and let's actually try and do that. And I'm going to run this with the comment, and when I execute, it says cannot drop the table dogs because it does not exist, or you do not have permission. Essentially, it's just saying there is no dogs table, and we know that because we deleted that already. But why don't we go to where we created this dogs table, and let's add another comment, and let's say creating our first table, right? So let's actually create this table again. So I'm going to run this with the comment, and when we do this, we can see that it says commands completed successfully, because what happens is that this comment is now totally ignored even when we run this query. But by adding this comment, we're sort of indicating a step, of what we're trying to do. So now we have our docs table again, and if we select all, we can see, okay, well, right now it's just showing, it shows the columns, but we've not inserted any records, right? So let's insert and I'm going to make a comment here as well. Let's say inserting records into our table. Okay, and now let's insert this record into the docs table, and if we scroll further down, let's select our docs table, and now we have Bella H4. So now we can go ahead and drop this table again, and I selected or highlighted both the query and the comment, and we can see that it's completed successfully without any issues. Okay, so I'm not sure if you know this, but just in case you don't, although I believe you do, you are amazing, and I'm not even joking. In less than an hour, you have come a long way. You've learned a lot, and I'm not gonna list everything you've learned, but if you're to take stock, this is a lot of information, and you're still here. So I would say thank you, good job, and you are amazing. So I'm thinking maybe we can add another 30 minutes of coding skills to your SQL toolbox. That way you can walk out of this session like a pro and feeling pumped. What do you think? We good, right? All right, let's do this. Just another half an hour and you're good to go. Let's talk a little bit about SQL command categorization and the different commands that falls under these categories. SQL commands are grouped into three main categories. We have data definition language DDL, data query language DQL, and data manipulation language DML. Now, these are not all of the different categories that we have, but most of your SQL commands will fall under these three main categories. Data definition language are SQL commands that are used to create and modify the structure of a database object. We have the create command, which is used to create database and its objects. By the way, when we talk about objects, objects in SQL really just means anything that points towards a data or towards data. So a table, for instance, is an SQL object. So if you remember earlier on, we used the create command to create a database. We also used it to create a table. We also have the drop command, which we used already. When we dropped a database, we used the drop database to drop one of our databases, and we also used it to drop our tables. So already we have covered both the create and the drop command. The last command under the data definition language is alter, which we use to alter the structure of a database. Assuming we need to add a new column to an existing table, so we want to alter the structure of that table. The syntax to do that is we have the keywords alter table followed by the name of the table. And since we want to add a new column, we have the keyword add, and then we have the name of the column that we want to add, the new column, followed by the data type of that column. Let's switch over to SQL Server and see what this looks like. So we already deleted our docs table, but not to worry because we can just run the query again to create that table. So we have the docs table has been created. Let's insert this record into the docs table. You know what? Let's actually insert this record because we have three records here. Let's insert these three records into our docs table. And now let's print out our docs table. Select start from docs, and this will print out all the records. So now we have these two columns, the name column, and we have the age column. We have Tom, 6 years, Wolfie is 5 years old, and Poggy is 4 years old. Now we have this table, assuming we need to add another column. Let's say we want to add a record of the colors of our dogs. The way this table is structured, we can't go back because this dogs table has been created already. And I'm just going to I'm going to copy this query. I'm just going to copy and I'm going to paste it right here. So because this docs table has been created, we can't just go and add a comma here and then say color. I'm just going to write color and varchar, let's say it's varchar 30, right? So if we try, and let's run this query, if we do this, it's going to tell us that there is already an object named dog. So it's really just telling us that we already have a table named dog. So we can't just go back to the schema that we created before and add a color column to that schema. That won't work. So the way to add another column, in this case we want to add a color column, would be to use the alter statement. Okay, I'm going to delete this because we don't need this. We don't need that there. But let's print out our docs table again. So I'm just going to go select all from dogs. Okay, so we have our docs table, we have the name and the age, and all we want to do now is to add a new column, and the name of the column would be color. Okay, I'm going to write out the query first and we'll go through it together. Okay, so let's go through this alter command. We're trying to add a new column, and this should be dogs. We're trying to add a new column to the dogs table. Okay, so the command is we type alter table followed by the name of the table we want to alter, which is the dogs table. Okay. Now we drop down and we have to tab to, and the reason we're tabbing is because this query depends on this alter table column command. So we kind of put it in a block of code. So we tab and then we type add, and what's the name of the new column we want to add? That's the we want to add a color column. What's the data type? So we include, because we know color would be, it's going to be a character, the values will be text or characters, if you will. So that's a string data type, and we know we use varchar for string data types, right? So we have varchar, and then in parentheses we include the total length of what the color can be. Well, I don't think there's any color that's up to 30 in the first place. Most colors might be under 10, but who knows? But we're setting it that the maximum name that falls under this color column should not be more than 30 characters. So now we can go ahead and execute. Commands completed successfully. And now when we print our docs table, we can see that we have a new column, which is the color. And we see that it says null, and this is because there are no values. We have not entered any values, like we didn't enter any color value for Tom, Wolfie, or Poggy, right? But we have achieved what we wanted to do, which is to add or insert a new column into our docs table. Let's go ahead and insert a new record into the docs table. All right, so we have our insert query. So we're inserting into the docs table. The columns we want to insert values into is, we have the name, we have age, and we have color. The values for the name, so the dog name we want to insert is Sean. The age is 3, and the color is gray. Let's execute. One row affected. And now when we print out our docs table, we can see that a new dog has been inserted. We have Sean, age 3, and color gray. And I'm just going to add a comment right here, and let's say making changes to the structure of our table. All right, so that's how we alter a table. What if we want to make another change to the structure of the table? Let's say we want to drop, or let's say we want to delete the age column. How do we do that? So we use the same alter statement, alter. What do we want to alter? We want to alter the dogs table. And this time, because we are deleting a column, we type drop column. And what's the name of the column we want to delete? And that's the age column. Now we can execute, and if we now print out our docs table, we don't have the age column anymore. The next topic I would like us to talk about is SQL constraints. Constraints are rules we enforce on our table to specify the types of data that can be stored in our table. Also, constraints can be applied on either the column level or the table level. So essentially, we can either pass a constraint on a column, enforce a constraint on a column, or we can enforce the constraint on the table as a whole. One of the constraints we have in SQL is null and not null. Null means unknown or missing value, so it's not the same as 0 or blank. Now, earlier on, and let's switch back to SQL Server. If we look at our dogs table, we have this field that says null. So essentially, we have null values for the color for Tom, Wolfie, and Poggy. Now, this does not mean that Tom, Wolfie, and Poggy don't have a color. It's just that we don't know, or we did not impute that record. And for us, we know maybe it's because we altered our table and added a color column, and at the time we didn't add values for Tom, Wolfie, and Poggy, and later on we added values for Sean and we added a color, right? But essentially, this null values doesn't mean no, it doesn't mean nothing or zero. It's just that we've not inserted any record, or we don't know what that record or what that value is. It doesn't mean Tom is colorless or Wolfie is colorless, right? So what if we want to enforce that whenever records are entered into our table, into our docs table, we want to ensure that a value is entered for the color of the dogs. So we want to pass a constraint on the color column to say that when customers enter maybe into a form, when they bring in their pet, we want to make sure that we have the name of the pet, we want to have the color of the pet, and maybe the breed of the pet, right? So we want to enforce that this field is compulsory and a value has to be inserted. To give you a more practical example, you probably have had to fill out a form that looks like this, either when registering for a particular service or you're buying a product. Visually, we know that the red asterisk is implying that that is a mandatory field. You have to enter some sort of values into those fields. But for us, as the owner or the service provider, we have to ensure that on the back end, we enforce that rule. Think about it this way. If you're registering for, say, a gym membership, one of the ways we need to confirm your registration is perhaps we have to send you an email. So it means we need your email. Maybe we definitely need your first name, we need your last name, we need a username for you to log into maybe your online gym membership profile, whatever the case may be. Of course, you also need a password. But for us, we need on the back end to enforce this rule. Otherwise, some people may choose not to enter maybe their email or a name that we need to provide the service for them. So how do we enforce this? On the back end, the service provider or this company would have a database that has been created to store the information of the customers. And that's really what we've done so far. We've been able to create a dog's table, a cat's table, and that's really it. There is a database that collects all that information. A table would have also been created in this form. So we have a table, the name of the table will be customers. We have the username that the customer has to create, a password, the first name, the last name, the email, the telephone number. And what happens is that now you go to this website to enter all of this information as this form requires. So you enter your username, which is really just an insert command, which we have done. Of course, you're not the one on the front end writing this queries or this code. What happens is that on the back end, these queries would have been pre-written, and there will be an application that really just, if you will, extract the information you enter into the form and extract that and put it into this pre-made codes and then insert the values into the table, which is in the database. But when we create our schema just the way we have, the schema that we see right there, the table schema, there's nothing really enforcing and ensuring that the client or the customer must input values into any of this field that we've indicated. So let's take a look at how we enforce that on the back end. Okay. So I have the schema that I have copied, and this is just to create a customers table. Let's quickly go through it. So we have the create table. The name of the table is customers. The first column is the username, which will be varchar. 20 will be the maximum characters of the username that the customers can create. We have the password. The maximum is 20 as well, which is varchar. The first name will be varchar 50. Last name varchar 50. And the email will be varchar 50 as well. And we have another column, which is the telephone number, which would be an integer. We close our parentheses and we add with a semicolon. So I'm going to go ahead and execute. So let's just see the table, select all from customers, and let's run this. So right now we just have the columns. We have not inserted any value, which is fine. We will do that now. So to point to what I was talking about earlier, assuming we have our, we have our form, or we have this website, we're collecting information for gym membership. And right now, the way the schema is, there is no constraint. So let's try and do that. Let's say we only want to insert the first name and the last name. So let's insert some records into our table. And then we want to insert. So what we want is we want to actually collect all of this information, right? That's what we want as the service provider. But let's say a customer, they go to the registration page and all they insert, because right now they're typing in their information, right? And all they choose to insert is the name, which is the first name. And they also insert the last name, right? And now we have values as, let's say the first name is Alex, and let's say the last name is Martins, and that's all the customer choose to provide. When we execute, and now let's print out our table, and we can see that that works. So the customer is able to decide now to enter a username, a password, an email, or telephone number, which doesn't really help us because we need at least the email and maybe the telephone number, some sort of contact. Once the customer register, we need to notify them, and we need to have records for our own purposes as well, right? So how do we enforce that when a customer goes on our website to register, that they have to input a username, a password, maybe the first name and the last name and the email as well? And this is where the null constraints comes to pass. So we want to pass a null constraint, okay? So to do that, the first thing I would like us to do, because I want us to use the same schema, but let's drop that, let's delete that table. So drop table, customers, and execute, right? So that's done. And now let's just copy the schema again. I'm going to paste it right here, and all we need to do is, if we want the username to be compulsory, so we don't want this column to be null, right? So all we need to do is, after the data type, we just need to type not null, and this is just indicating, this is telling, by this way, enforcing the constraint that this value cannot be null. The password as well, we say not null. And then for the first name, because we would need the name, not null. And let's say we want the last name to be compulsory as well, not null. And we need the email as well, not null. And let's say we're fine with them not, including the telephone number, right? So now let's create a schema, execute. Now let's try and do what we did earlier, which was to just insert the first name and the last name without other values. So let's just execute, and immediately we can see there is an error message which says cannot insert the value null into the column username. So it's saying that we have to insert a value into username, right? Now you as a customer would not see this, when you're trying to, and you've probably observed this in the past. You put in an information, and then you get a pop-up message that shows you that you've missed a particular field, and there is another application that then displays something else. It's not going to show all these jargons, because that won't make any sense to a user. So there will be an application that on the front end just shows, oh, you've missed this, enter a username or enter a password or retype your password, something like that, right? But by doing this now, we have enforced that constraint that when a user go to our website, they have to enter all of those values. So now let's enter a proper value into this field. So I have a query already, an insert query. And so this is going to insert values into username, password, first name, last name, and email. And you know what? Let's just exclude the telephone number since that's not compulsory, just to show you that it will work because we did not pass the not null constraint on the telephone number. So I will take this away as well. And now let's execute when we're affected. And if we print out our table, so select all from customers and execute. Now we have our table, the username, the password, the first name, the last name, the email, and then we don't have any value for the telephone number, which is fine because we are fine with the customer not imputing their telephone number. So this is how we pass a not null constraint on a column within our table. And I'm just going to make a comment right here, and we'll just call this the null constraint. Okay. Let's take a look at one more constraint. We also have the default constraint, which is used to display a specified value when the insert into statement does not provide a value. To explain the way default constraint works, let's assume that we need to collect voters' information in the state of Florida. And we only need basic information, maybe just the first name and the last name of the voters. But we also have a column that shows or captures the name of the state, which in our case is Florida. Now, because we know all the voters will be in Florida, perhaps we're fine if the voters don't enter that information, but we want to still display that information. Let's switch over to SQL Server, and this would make more sense. Okay, I'm going to make a comment, and we'll call this default constraint. All right, so what I'd like us to do is to create a new table, and we will call the table voters. So create table voters, and we like to have the first name of the voters. This will be varchar, and we'll make it varchar 50. We will also want to have the last name of the voters. We have that as varchar, and we'll make that varchar 50 as well. Now, let's say we have a third column which captures the city of our voters. Okay, so we'll say city, and this will be varchar as well, and we'll make it varchar 50. Okay, but we want to make this field optional, so we're fine if the voters don't enter this information, but we still want to print out the name of that city. Now we can use a default constraint to say that if the voters do not enter a value into this column, I want you to print out a specific value. And to do that, all we need to do is we type default. And what's the default value that we want? It will be, let's say London, okay? So that's the default value that we want. So this is saying that for the city, I want you to print out a default value of London. Now, if and we have to close the parentheses there. Now, if the voters do enter a value, it's going to show that value, but if they don't enter a value, then print out London. Let's create a table, and now let's just insert some records. So let's insert this record, execute, and now let's print out our table. Select all from voters and execute. So what we see here is that even though we did not enter a value into the city, we have a default value printed out. Now, assuming, and let's copy this query again, and I'm just going to paste. Now, assuming that the voter decided to enter the city, and let's say we're going to add the city into the insert query. Now, and I'm just going to delete this because I just want to enter one record. So let's say we have another voter that for some reason is from another city. I'm not sure how that happened, but let's pretend this voter is from actually a different country, like France, right? Now let's enter this record, and you know what? Let's add an. Actually, no, that's fine. So let's enter this, execute, and now let's print out our table. So we can see that because the user entered a value of France into the city, that overrides the default value of London that we set when we created the schema for our table. So the way the default constraint works is that if a value is entered into that field, then that value is displayed. But if a value is not entered, then we have a default value that is displayed or entered into that field. I would like to take this moment to say a big congratulations to you. You should pat yourself on the back. In fact, get yourself a glass of wine, bottle of beer, ice cream, whatever you celebrate with, and toast to yourself. Imagine from knowing little or nothing about SQL, you now have the skills you can build on towards becoming an SQL developer. Let's take a look at what you now know. We started our SQL journey talking about data, databases, and database management systems, and the relationship that exists between all of those concepts. Then we talked about how SQL is the language we use to communicate with our database within a relational database management system. Subsequently, we looked into SQL dialect and established that once you know SQL, you can pretty much work with any relational database management system because they all use SQL to communicate with a database. We then discussed the main data types in SQL, which is the numeric, string, and date and time data type. Now, we did not get to try our hands on the date and time data type simply because there is a lot to unpack with date and time functions, and we don't have a lot of time to actually work on that. Subsequently, we learned all about tables, how to create tables, and also creating the schema for a table. Then we learned how to add comments within our SQL queries. We learned different commands that falls under the data definition language. So we created our databases, we created tables, we learned how to delete a table or database using the drop command, and we also learned how to alter the structure of a table. Then we moved into SQL constraints, where we learned how to use the null and the not null constraint, as well as the default constraint. So you may be thinking, where do I go from here? And is this all I need to learn in SQL? Although there is still a lot you need to know, but with what you have learned today, you are